Okay, so in this lesson, you're going to use the graph of a one-to-one function to graph its inverse on the same axis. Now, one thing you have to remember is that the inverse functions are symmetrical about the line y equal x. Okay, so if you look at that first example right here, so here's my function, and I want to graph its inverse. I want to graph the inverse of that function. So first of all, notice that this function is one-to-one. So as long as that function is one-to-one, I can graph its inverse. It's going to have an inverse function. All right, to graph the inverse function, remember where inverse functions are symmetrical about that line y equal x. So use the line y equal x to help you graph its inverse. All right, so I'm going to draw the line y equal x in orange. So remember y equal x, y equal x. So when x is 1, y is 1. When x is -1, y is -1, and so on. So when y is 1, when x is 1, y is 1. When x is 2, y is 2. When x is 0, y is 0. When x is -2, y is -2. Okay, so this is a line right here, and I'm going to make it dotted. So this is a line y equals x. All right, so I'm using pins. I'm trying to do the best I can with this. All right, so this is a line y equals x. So to graph the inverse of this, I'm going to use this idea to help me. I'll use the line y equal x to help me graph its inverse. Now, one of the things you got to remember, y equals x, x equal y, right? So think of this as the x and y being interchanged. So what you may want to do is this: locate some points on this line. That's a line, so it'll be easy to graph its inverse since it's a line. I want you to see this. See this right here? This point here is on that line, right? So that's that point 1, 4. Well, if 1, 4 is on the function, then on the inverse, you're going to interchange the coordinates, and that's going to be the point on the inverse. So 1, 4, remember this is 1, 4. 1, 4 becomes the point 4, 1. So 4, 1 on the inverse right here. So this is 4, 1. Okay? And then let's look at another point. See this? Here's another point right here. 0, 1. 0, 1's on that line. So 0, 1 becomes the point 1, 0 right here. And remember, that's a line, so all you need to do is just graph the line now, and there's your, and I'm going to go ahead and use blue rather than black because the function f of x is in black. So let me use blue. And so what I'm about to draw is going to be the inverse. So here is the inverse of this black function. You see this? See how they're symmetrical about the line y equal x? See that dotted line? Looks symmetrical, right? And then just remember, see 1, 4 became the point 4, 1. See right here? 1, 4 became the point 4, 1. I'm not going to draw this line, but I want to show you. So if you were to connect this, though, then if you connect this, that segment that you would draw, if you did, don't do it, but that segment you would draw would be perpendicular to this dotted line. Same thing here. See the point 0, 1 became the point 1, 0 right here. So when you draw that segment right here, it will be perpendicular to this dotted line. All right. And so that is the graph. So that's the inverse. So notice it's pretty easy. You just find some points in the original function, interchange the coordinates, and then use the y equal x to help you make it look symmetrical. All right, so that's the first one. Let's get the second one. So in the second one, we have this function. Now this is curved, so it's going to be a little bit more difficult, but it's still doable. Do the best you can. Let's go ahead first of all and graph the line y equal x. So y equal x, remember graphing the line y equal x. So y equal x means x and y are the same coordinates. So 1, 1, 2, 2, 3, 3, right? 0, 0, -1, 1, and so on. All right, so here is my dotted line. right here. Let me make it a little bit better. All right, so here is the line y equal x right here. Oops, I already messed up. Okay, y equal x. Okay, so that orange is the line y equal x. Okay, now I want to use that to help me graph its inverse. All right, so to graph its inverse, pick some points that you know are on that line. Like, see right here, it looks like that's on that line, right? Here and here, it looks like, right? Okay, so the point, this point here is 3, 4. The point 3, 4 on F becomes what point on the inverse? Remember, you interchange the coordinates. So on the inverse, you'll get the point 4, 3. So 4, 3 is here. 2, 2 stays 2, 2. Now 1, 1 stays 1, 1, it looks like. And okay, so that's about it. So that's going to be a little bit more difficult, won't it? All right. So you see right here, let's think about this right here. Let's estimate this. See this right here. Well, but you can see this where it crosses the where the black graph crosses the y-axis. Let's say that's the point 0, 1 fourth. So 0, 1 fourth becomes the point 1 fourth 0 right here, right? Okay, so let's go ahead and see how it's going away from the line y equal x, how it's going towards the x-axis as well. Do the same thing here, watch. Just do this. Looks like this, and then kind of does this. Oops, and I may have messed that up, but yeah, I think I messed that up somewhat. Let me make sure. 3, 4 became the point 4. Oops, I did. I'm sorry. Let me go ahead and erase this. And I'll tell you what I did. You see, 3, 4 becomes a point 4, 3, right? I put 4, 2. So let me go ahead and erase it and put 4, 2. I'm at 4, 3. All right, so now I'm going to go back and plot the point 4, 3. So 4, 3 is here, right here. All right, so let's connect those now. It looks a little. Now it's going to look better. And it looks something goes away. See how it's going away from that line y equals x? Make it look symmetrical like this. Okay? And so that's it. So there's the graph. See how it looks symmetrical? Just the best you can with the curves, okay? All right. So that's number 2. So that was number 2. All right, let's look at number 3. So number 3, I have another curve. All right. All right, so let's graph the line y equal x. So y equal x is 0, 0, 1, 1, 2, 2, and so on, right? So let's go ahead and graph the line y equals x. We're going to use that to help me draw my inverse. So I'm making it dotted. So there's a line y equal x. All right, and let's use some points that are on this curve to help me graph its inverse. So there's f of x. So notice, see some points here, right? And let's look at their ordered pairs. So this point here is negative 4, 0. So negative 4, 0 on f of x becomes what point on the inverse? Well, you interchange the coordinates. So 0, negative 4. So see how this point's on the x-axis? On its inverse is going to be on the y-axis. So the x-axis, y-axis. This point here is negative 3, 1. Negative 3, 1. So negative 3, 1 becomes 1, negative 3 right here. You see how this point's on the y-axis right here? So on its inverse, it's going to be on the x-axis. So the point 0, 2 becomes the point 2, 0 on the x-axis. Now, wherever, let me just say this, wherever a graph crosses the line y equal x right here, that's where the inverse will cross it as well, okay? So wherever the graph crosses the line y equal x, that's also going to be a point on the inverse. And then right here, see this point that is 5, 3? So 5, 3 becomes 3, 5 right here. 1 right here. All right, and so then you just draw it and it looks like this. Okay, there's the graph. So see, it kind of looks like, I guess I could have done a little bit better job here. But it looks symmetrical about that line y equals x, doesn't it? All right, so there's the inverse. So that's inverse of x. So that's number 3. Okay? All right, let's look at number 4. So in number 4, we have Now these are segments, so segments are easy to graph the inverse for. Segments are easy to graph. So let's go ahead and graph the line y equal x. So that's going to help us to graph its inverse. So 0, 0, 1, 1, 2, 2. And then let's go ahead and draw our line y equal x. Let me go ahead and do this. Okay. And remember we said, so see where that f of x crosses the line y equal x here? For the inverse, it's going to do the same thing. So right away, I know I can put a darker circle here. Okay, so you see this point right here? Now remember, these are segments, so there are no arrows at all here. This is a segment. So you see this point here? That's the point -6, -5, right? So the point -6, -5, on the inverse, it'll be the point -5, -6. So -5, -6, right here. Okay? Let me make sure that was correct. -5. Oops, sorry. That's -6, -5. -6, -5 becomes the point -5, -6. Okay, right here. And then it's not looking symmetrical here because I didn't draw the dotted line well. It should have been a little bit further down, but that's okay. See this point here? -4, -3 becomes the point -3, -4, right here. This point here, -3, 1 becomes a point 1, -3. This point here, now remember, whenever your graph is made up of segments like this, always use the endpoints of each segment, okay? So you see this point here, that's the endpoint of that segment. That is the coordinates 1, 4. 1, 4 becomes 4, 1. And then right here, the end of that segment, this was 7, 6, becomes the point 6, 7. So 6, 7 is right here. Okay? All right, so let's connect these segments. So this segment, this segment, this segment, this segment, and let's see, let me make sure I do this right. So that's 7, 6 becomes 6, 7 right here. And it should have been a little bit further right here, I guess. All right, so I kind of messed that up a little right here because it's not supposed to be vertical up because it would no longer be a function. So I should maybe go a little bit further this way. So I did somehow mess this part up. But anyway, so that's what it looks like. Okay, see how those are looking symmetrical? Now, should really, see, this is 7, 6. I'm having a little trouble here because it's not supposed to be going straight up and down. Let's see, it should have gone more like this, I guess. Let me kind of erase that, make it look a little bit better. Okay, so what I did was I erased this, and to be honest with you, when I drew those segments, I did it by hand. I should have used a ruler to make it straight. See how it didn't look straight here? All right, so it's kind of my fault for drawing these without using a ruler. So right here, it should go, this segment, see how this segment goes from here to here? It's supposed to be straight, and I did this by hand without using a ruler. So from here to here, this point here, 7, 6 becomes a point 6, 7 right here. It should, let's see, should do this. Oops, should do that, okay? And then this right here would be where this segment intersects that y equal x right here. So I did put in the wrong place. All right, so I did kind of mess that up. And anyway, so it looks symmetrical in most of it, doesn't it? All right, so it's pretty easy, and I made it look difficult, but it's pretty easy to draw the inverse when there are segments given. And it helps, though, if you use a ruler to draw those segments like I did not do, but it does help. Okay, so that was number 4. That was number 4. All right, let's look at number 5. Okay, so the final one, number 5, so it's a curve, but that's not that difficult because points are given right here, right here, right here, right here, and right here, it looks like. All right, and then again, we're going to draw the line y equal x. So y equal x, 0, 0, 1, 1, 2, 2. So y equal x. So x and y are the same. So notice x coordinate and y coordinate the same, x coordinate and y coordinate the same, x coordinate and the y coordinate the same. So when I graph this y equal x, I'm going to use a dotted line, something like this. And, all right, so let's see what we get. So this point here is negative 6, 3, right? So negative 6, 3 becomes 3, negative 6. 3, negative 6, right here. This point here is negative 4, 5. Negative 4, 5 becomes the point 5, negative 4, right here. This point here is negative 1, 7. Negative 1, 7 becomes 7, negative 1. This point here is 4, 9. 4, 9 becomes 9, 4. 9, 4, 9, 4, right here. This point here is 9, 10. 9, 10 becomes 10, 9. So I guess about, I have to estimate where 10 is right here. 10, 9, about here. All right, and so remember, these are, just make it look curved the best you can. Something like this. Let's see, just make it look curved like this, okay? And with an arrow. All right, and so notice that it does look symmetrical. Hopefully it looks symmetrical. Okay, see that? Looks symmetrical. All right, and so that is it. So oh, by the way, this is the inverse. Inverse of x, and this was f of x here. All right, and so that was number 5. All right, so that's how you're going to graph the inverse. You're going to draw the line y equal x, and then you're going to interchange the coordinates. That's all you're doing, and just kind of make sure it looks symmetrical about this line y equal x. Okay, so that is the lesson on using the graph of a one-to-one function to graph its inverse on the same axis.